So first things first, warm up question, and I'm just going to write them down and then I'll put it on the TV. All right. So 3x plus y less than 4. And I'm solving for y. So what do I do first, Benito?
You drop down to -3. I'll be right, -3, move it over.
Okay, so you're going to minus 3x. Yes. So y is less than 4 minus 3x. Is y by itself now, Race?
Yes.
Yes. Okay, I just need to shuffle the order. What's the correct order? Shall we take your headphones out? What's the correct order to write this in? John, how do I get this in mx plus b form?
I swap in the line so
Yep.
y equals -3x plus 4.
Y less than -3x plus 4. Perfect. If I were graphing this, let's check. I know this wasn't on the warm-up, but we need to remember this from last week. When it's just a less than sign, is it a dashed line or a solid line? Look at do you have your notes? So remember this, when we had just number lines, was it open or was it shaded when it was just less than?
Open.
It was open because it doesn't include it, right?
Yeah.
So your line has to be dashed because it doesn't include all of those points. So this would be a dashed line if I graphed it. Would I shade above or would I shade below?
Above.
Does this say y is bigger than
Less than.
this line? It says y is less than, correct? So remember, I find the y-intercept and I'd go down. So it'd be shaded below based off that symbol. And I guess if I wanted to be better, I could have drawn my line as a negative slope and then shaded down below. So probably to look something like this. Yes, ma'am.
So if it was less than, would you shade above?
No, less than is what this is, so it's below.
If it was greater than?
Yes. Yep. All right, on the next one, I need to get y by itself. What's the first step, Miranda? Minus 4. 2y greater than 3x minus 4. What's next, Albert? Who's going to pull that mask up properly?
You would divide by 2.
Yep. Both sides. So y greater than 3 divided by 2 becomes what?
3/2.
Yep, just the fraction. 3 over 2. Good. Negative 4 divided by 2 becomes awesome. Okay, so if I was graphing this one, solid or dashed? Does this have an equal to? It's got to be dashed. Would I shade above or below?
Above.
Yep. Switch this word. Dashed. And I would find the y-intercept and I would shade above like so. Because it's greater than. Okie dokie. All right, so we're going to take this skill and we're going to put it together and do it twice in one problem to get our answer. So if you can do this, if this made sense, you're going to be just fine. Don't stress, okay? If you can't do this, still don't stress because it's going to still be just review. So you'll pick it up. Don't worry. But that's what we're doing today. We're going to essentially just graph 2 lines at the same time and do some shading. And where the shading overlaps is going to be our answer. So by the end of this, you'll be able to graph the solution set for a system of linear inequalities, and you will determine whether or not a point is in the solution set for that system. So starting with bullet number 1, when we graph an equation, the line represents every solution to that linear equation. So that's when it's in y equals mx plus b. The only solutions, the only points that will be true are the ones on the actual line because it's an equal to sign. When we graph an inequality, oops. An inequality, the solution is represented by an entire region, or you could say area, not just the line. We represent this region by shading it in. So remember we talked about that last week, how the solutions were all the things in the shaded part. Just go. You don't have to ask. We graph a solid line if the line is included in the solution. So remember, if it has the equal to, it's solid. We graph a dashed line if it is not included. So when it's just greater than or just less than. If y is greater than the expression involving x, shade above. It's otherwise shade below. So when it's less than, we go below. The solution region is where the shaded region is overlapping. Okay, so I know that this is kind of hard to see because it just looks like one giant color. But we are going to, if you have colored highlighters and you want to use them, you can, or a color pencil or pen or something, you may do that. If you don't, I will get you a couple real quick. Give me 1 second and I'll get some out. Highlighters. Lydia, highlighters. Art. Miranda. John. What are you going to use as your two colors? Color? Highlighter? Highlighters? Yes, no? No? What is your, you're doing pen and pencil? You good or you want highlighters?
Actually, yeah, no.
Highlighters? Grace, you good? Grayson?
I have
Okay. Cameron?
but thank you.
Yep. Alright. Alright, so on this first box, it says top equation. So that is this one. Okay, so highlight it so it matches, color, circle it if you're using pen and pencil or something. So that first one has a y-intercept of what?
5.
And a slope of 2. Now, less than, is that line dashed or solid? Dashed. Is it shaded above or below? Below. So this one should be colored over here below the line. All of that. All right, and then I want you to do it again over here on this one. We're shading both the top and the bottom on this one, so we're going to color this one in the same area over there. Okay, now the other equation says y greater than or equal to -1/2 x minus 1. So for this one, is the shading above or below? It's greater than, so it has to be above. Is that a solid line or a dashed line? Solid, so it should look like this. So all of this, and I kind of went over the line. Be a better colorer than me. Stay in the lines.
That's the reason I'm not in art.
That's the reason why I'm hard. You're an art.
All right. So now the final solution is where the two colors overlap. So you see how the yellow and the green are both here?
Yes.
That's your solution. That's where they overlap. So in your answer, if you'll get it to look like this, you would just draw an arrow and you'll put solution. They just dropped off the extra to show you the only shaded region. All right. So do we see how this is the same thing we were working on last week? Just put together. Yes?
Yes.
Okay. To the back. Some examples together. So, number 1, x plus y greater than 2, negative 4x plus 2y less than 8. So the first thing we have to do is get what letter by itself?
Y.
Yep. All right, so I'm going to rewrite this up here so I have room to work. What do I have to do first to get y by itself on that equation there, Cameron? What do I do first? Yep, minus x. So y is greater than 2 minus x. And I rewrite it, if you need to, negative x plus 2. And that's what I'm going to graph. All right, so let's graph it. So negative x plus 2. What's the y-intercept of that one?
Positive 2.
Positive 2, good. So I'm going to go up 2, and I'm going to put a dot. What is the slope of this one?
Negative 1.
Right, so this is a negative 1, good. And then remember, we put whole numbers over 1. Awesome. So we're going to go down 1, right 1. Down 1, right 1. Down 1, right 1. Forever and ever. After you get a few, connect your dots. Make sure, don't be lazy, connect your line all the way to the edge of the graph so that you don't shade in the wrong area. I would hate for you to get it wrong because you just didn't draw your line all the way out. Oh, yeah, good call. It is a dash line, so I should probably erase some of this. Yep.
Perfect.
Just go erase. That's all I'm doing. I didn't have to redraw it. There's a dash line. Now, am I shading above or below? So greater than is smaller numbers? Above. It's greater. So remember, y-intercept above there. So it's got to be this area here. Okay? Use your highlighters right now. All right, next equation, I have negative 4x plus 2y less than 8. What do I have to do first?
Bring down the floor.
Bring down.
Well, like make it a funky.
Yep, add 4x to both sides. The same one. Remember, we got to do it twice. 2y less than 8 plus 4x. What's the next step to get y by itself there? What do I do, Grayson? By? What numbers with y?
2.
Yep, divide by 2. So y less than, what is 8 divided by 2?
4.
And what is 4x divided by 2? 2x. If you need to shuffle it, y less than 2x plus 4. So that's what I'm going to graph. right. What's the y-intercept of this one?
4.
4, the number on its own. 1, 2, 3, 4. Okay, what's the slope of this one? 2 over 1. Because remember, it's a whole number, so I put it over 1 as a to make it a fraction. So I have a rise over a run. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Oh, my hero.
It's like a donut.
Yes, I will.
And it's not
Okay, so is this one dashed or solid? It's dashed again. There's no equal to. So when I connect these, leave a little bit of space. Do I shade above or below this one?
No. Yeah.
It's less than, so I would go down from my y-intercept. So we see where it overlaps. So all of this, anything in this area is a solution. Anything in that orange part on mine is a solution. I am really
Really what?
eating my donut.
That is like eyeballing you.
All right. Nice. 3x minus y greater than or equal to 2. And then y greater than 3x plus 5. Okay, that second one's already done for you, right? Y is already by itself?
Yeah.
So let's graph that one first and get it out of the way because there's no work we have to do. What's the y-intercept there? Yep. The number out here. So I start at positive 5. And then the slope is 3 over 1. 1, 2, 3. 1, 1, 2, 3. 1. Solid or dashed?
So,
Does it have an equal to?
no.
Yep. So it has to be dashed. Shade above or below?
Above.
Above because it's greater than. All right, next one. I got to do a little bit of work on the next one. So 3x minus y greater than or equal to 2. What's the first step to get y by itself here? Minus the 3x. Don't forget your x. So negative y greater than or equal to 2 minus 3x. Okay, what's the last step? Divide by negative 1. And what happens when I divide by negatives?
Switch the component.
So this is going to become y less than or equal to, what is 2 divided by negative 1? What is negative 3x divided by negative 1? Positive 3. One more rewrite if you need it. 3x minus 2. And that's what I'm going to graph.
Solid line.
It is a solid line. You are correct. All right. So what's the y-intercept of this one?
Positive.
Positive 2?
It's negative.
Remember, we divided 2 by negative 1, and we got negative 2, and so that goes on the end. All right, so negative 2. Slope of this line?
3/1.
Positive 3 over 1. 1, 2, 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 3 over 1. So when I connect these dots with my solid line, as Cameron told us,
This one's solid, right?
Yep. Am I shading above or below?
Above.
Is it less than or greater than?
Less than.
So is it so it's below. So is there any part that overlaps?
No.
Nope. So there is no solution to that one right there. Yep. You are correct. If the lines are parallel and the shading goes the opposite ways, there is no solution. Oh man, now we got some Hoy and Bucks line. They just never disappear. All right, so that top one, is it Hoy or is it Bucks? It's Hoy, so is it horizontal or vertical? Horizontal, so I go to -4 on the Y, and I put a dot. Solid or dashed?
Solid.
Okay, Grace, pull your mask up, please. Solid line. Oh shoot, that is not on the line. All right, solid. Shade above or below? Greater than, so we're going up, up. Will be up above here. All right, the next one, Hoy or Bucks?
Boy.
Bucks, it has an X. So this one's vertical or horizontal? Vertical. 1, 2, 3, 4, 5, 6, 7, 8. Solid or dashed? It is dashed. Solid. What? What's it equal to? Oh, I thought you said solid. Sorry. All right. And then less than. So with the X's, does that mean I go to the left or to the right? Remember, when it's just X, we treat it like our old inequalities and we follow the symbol's direction. So this one's pointing to the left. So I would shade everything to the left of my Bucks line. And so this part that's in orange, that is my solution. The part where it overlaps. Grayson, put it away. Or I'm going to stop letting you charge it. All right. Did we get all three of those done? Okie dokie. We got one last problem here together. And then we are going to work on our assignment. So Philip makes $15 per hour working for a photographer. He also coaches a soccer team for $10 per hour. He needs to earn at least $90 per week, but is unable to work for more than 20 hours per week. Write a system of equations to model the situation. Assign X to the photography job and Y to the soccer job. Okay, so first things first. My mind, the easiest equation to write is the total hours one. Because X is your soccer hours, X is your photography hours, Y is your soccer hours. And what is the maximum amount of hours he can work? 20. So if he cannot work more than that, would it be a less than or equal to or a greater than or equal to?
Less than equal.
It would be less than. So X hours plus Y hours has to be less than or equal to 20. Now, how much does he get paid per hour of photography? 15. So I write 15x, right? 15 times the hours. Per means times. How much does he get paid per hour for soccer? 10. So that's $15 per hour plus $10 per hour. How much does he need to make?
90.
At least 90. So what should my inequality be?
Greater than
No.
equal.
Greater than or equal to $90. 90 would be okay. That's why it has the equal to. But 100 would be even better. That's why it's greater than. Okay? So now we need to solve these for y so we can graph them. All right? So the first one, what do I do to get y by itself out of that first inequality? Yep, minus x. So y is less than or equal to 20 minus x, or negative x plus 20. All right, then the next equation, 15x plus 10y, or inequality, I apologize. How do I get y by itself there? Minus 15x, yep, but the x piece, you're right. So 10y greater than or equal to 90 minus 15x. Last step, divide by 10. So y is greater than or equal to, what is 90 divided by 10? What's negative 15x divided by 10? Other way.
3 over 2.
3 over 2. 3 over 2 x. If you need to rewrite it, negative 3 over 2x plus 9. I'm going to move it up. Okay, so now we got a graph. So the first one, what's the y-intercept of this first one? 20. The first one, 20. So I'm going to go up to 20. What's the slope? Negative 1 over 1. Okay, these are counting by 2's, yes? But as long as I go the same, it's the same, like negative 2 divided by 2 is negative 1 still, right?
Yes.
So I can go down 2 over 2, down 2 over 2, down 2, etc., etc., etc. Would this be a solid line or a dashed line? Mm-hmm. Do I shade above or below?
Below.
Below. So I'm going to go from my y-intercept down. So it's this side. is this line? Okay. What's the y-intercept of my other inequality?
9.
9, yep. So I'm gonna go right here. What was the slope of it?
3/10.
Positive?
Negative.
Negative.
Okay. So if I go down to 6, that's -3, correct? Then I go over 2. Then I go down to 3, over 2. Down to 0, over 2. So here's my other lines. Also solid, right?
Yes.
But do I shade above or below on this one?
About.
Above.
Either way, there's a solution.
Either way, what?
Either way, there's a solution.
There is a solution, but we got to make sure we have the right solution. All right. So the solution, is it the pink, the yellow, or the orange? The orange, yep. This is your solution. So here's the, make sure you know this. Any ordered pair in this area is a solution. Okay, one of your Delta Math assignments is going to ask for you to give an ordered pair. So if I asked you to give me an ordered pair, you could say 6, 8. 6, 8 is in there, so it is a solution. Okay, you could tell me 14, 2. That is a solution. But if you tell me 16, 16, that's not in the shaded part, right? That's not in the overlapping part. So this is not a solution out there. If you told me 2, 2, that would also not be a solution. It has to be in here to be a solution. Yes?
Mhm.
Okay. So you have a Delta Math assignment. You need to get a Chromebook. Get on it. If you need a piece of paper, look, I magically have these up here in my classroom. Grab a piece of paper. That way you can show your work because you will have to be solving for y